Any musicians in here? Nathan. Oh man.
I'm a musician.
What is music like vegetables?
I was thinking VeggieTales.
Oh, like the show VeggieTales?
Yeah.
Like
It's
VeggieTales.
tastes bad.
VeggieTales.
You know, I never got into VeggieTales as a child.
Fair enough.
But I'm pretty sure there's music involved.
What is music like? Not quite. Not quite. Any other guesses?
Yeah, I don't want to be rude, but anybody that didn't get into VeggieTales as a kid is an idiot.
Wow.
That's not pointing towards just any one person, but
I mean, I feel like it kind of was like directly pointed to one maybe person.
I don't think so. I don't know, man.
Fair enough. When you got the beat, you got beets. That's the answer. Beets is a vegetable. How cool is that?
Beets.
Beets.
Never eaten a beet before.
You've never eaten a beet before?
No.
Huh.
Is that part of our culture?
Yeah.
Really?
Yeah.
That's like American.
I mean, I feel like it's like worldwide. I mean, it's a vegetable. Everybody knows what a beet is.
I've never heard of that before.
Wow.
I don't think my family ever brought home a beet.
Interesting.
Yeah.
I don't know what they say about beets.
Are beets even good?
Not
No,
really.
obviously not.
Yeah.
like,
If they were good, my family would be bringing them home.
Okay, fair enough. Fair enough. All right. So we got last 2 days we've been learning about oxidation numbers, right? All right, that ties directly into redox. That's what we're learning, redox. Okay? So when looking at redox, okay? That's the title of our chapter, right? Redox. The first part of the word, oh, that's terrible. First part of the word is a reduction. Okay? So some things are reducing. Other things is called oxidation. Okay, so we have reduction and oxidation. That's what we're doing. Easy enough?
oh yeah, that's pretty easy.
Okay. Now, there are two ways you can remember oxidation and reduction. Oil rig. Can you remember oil rig?
I'm really bad at memory.
Can you remember Leo the Lion says grr? Which one sounds easier to remember?
The first one.
Oil rig?
Oil rig.
Oil rig. All right. So, what oil rig is? Let me pull this up here.
Not really good oil out of it.
That's exactly what it is.
Yeah.
Okay. So, oil rig. I'm going to write that down. I don't want to mess this up. So, I'm going to write it down like right here. Yeah. Is that how you would spell oil rig?
Yeah.
That's how I would spell oil rig. Now, remember, this entire chapter is about electrons. So, oil rig. Oil is oxidation. Let me make sure. Is loss. Reduction is gain.
Reduction is
Gain. Okay. Loss of what? Gain of what?
oil.
Not quite. This entire chapter is about
Oxidation.
electrons.
Electron.
The whole chapter is about electrons. So, oil rig. If we can remember oil rig, oil, oxidation is losing electrons. Reduction is gaining electrons. Wow.
Reduction sounds like you're losing it. That's just my 2 cents.
See, that you're not going to like this. You're not going to like this at all. Because it's opposite. So
Oh.
reduction is gaining electrons. Right? It is kind of silly. The other one was Leo the line and says, Gert, you like that one. Lose electrons is oxidation. Gaining electrons is reduction. Same exact thing.
That feels like too much of a stretch.
Yeah, oil rig's better.
Yeah.
All right, fair enough. Okay. So, how in the world does this relate to what we've learned last year?
It doesn't at all.
Oh, that'd be crazy, wouldn't it? It's just like, hey, we're starting from scratch.
We're doing Rube Goldberg's next week, but I'm pretty pumped.
That is pretty pumped about. I'm pretty pumped about it. All right. So, when you see an example like this, oh, I was for sure I was going to get on my first try. Oh,
Oh, my. Third try.
third try? I was going to give up, but Terry said go again.
Never gonna give up.
Oh,
Oh my.
I could do this all day, honestly. Ooh!
Never give up. That's what I was-
Never give up. Life lesson right there. Right?
Yep.
All right. When I'm looking at this, I have to assign oxidation numbers to every single one of those elements. We got to look at all our rules. We got to look at our rules. Okay? So, for example, what's the oxidation of chlorine? What's the oxidation of chlorine? One?
Yeah.
You're super close. Daniel? -1. Okay, so chlorine is -1. I know that. Okay. Now, I have 2 of those. So that's going to be a -2. What's that going to make my SN? 2. Very good. Okay, so SN is 2. Chlorine is -1, right? Do we remember that? Okay, let's go to this one. What's chlorine? -1. Very good.
-1.
-1. Okay. I have 4 of those.
-4.
So what must my lead be? 4. Okay. I got those 2. We're over halfway done. What's chlorine?
-1.
-1. Holy smokes. We're kind of crushing this right now. I have 4 of those. So what must 10 be? 4. Holy
4.
smokes. We're doing so good. Okay. Chlorine is what?
-1.
I have 2 of those this time. So what must my lead be?
-2.
2. I feel like that was super easy. I don't
It
know.
looks easy when it's up on the board, but then when you give it to us, it's like more concept.
I get that. So, when we hear what is reduction, what is oxidation? Okay? So, if you look at chlorine, does its oxidation change? Does its number change? What's it here? They're all -1. It doesn't change, does it? So let's ignore that. I don't care about chlorine. You know what I'm saying? It doesn't change. It doesn't. Who, me or chlorine? For both rude? I don't really care about this chlorine.
More rude.
Okay? What I care about is these numbers. And the reason I care about these numbers, 10 right here is 2. What's it there?
2. 4.
4. The number changed? How's that possible?
Not. They'll just made it up.
Now,
That's the question.
so what you got to think about adding electrons, right? All we're talking about is electrons. So how many electrons have to go here to get my number to be the same as that? Remember, electrons are subtracting, right? So maybe if I add 2 electrons to that, what is 4 minus 2?
2.
Oh.
Oh.
Now, so if I started with this, I gain 2 electrons, or actually, we're going backwards. That's my bad. That's my bad. Holy smokes, we're actually losing 2 electrons. That was my bad. If we lose 2 electrons, right? So let's think about this in a conceptual way. This marker is being mean, you know? It's a mean marker. It's very negative. I don't like it. So I leave that marker. I become a little bit more positive now, right? If you lose a negative marker, I'm starting to feel a little bit better. You know what I'm saying? Do you know what I'm saying?
Yeah.
It's just like when you lose a negative, you start to become positive. Okay? So if you lose 2 negatives, you start to become a little positive. So we lost negative. So what is being oxidized?
Yeah, I'm lost.
All right, where did I lose you?
I don't really.
Were you good right here?
Not really.
You didn't know how we got our oxidation numbers? Oh.
Do I look like I knew that?
Maybe I'll come back on the next example.
Alright.
So this went from 2 to 4. So in order for it to increase, we had to lose negatives. Lose the negativity. Right? And we had to lose 2 of them. So which one loses electrons? Oxidation. Oxidation is loss. All right, so we lost the electrons. So tin is being oxidized. Now, if we look at PV, PV goes from 4 to 2. 4 to 2. Now, this is crazy because now we actually gained negatives, right? From 4 to 2, we had to go down. We subtracted. We gained negatives. So that would be our reduced. And honestly, if you just want to think about it, which numbers were reduced? Well, 4 went to 2. 4 went to 2. 4, that means it was reduced. That's a pretty nice way to think about it. Know what I'm saying? 4 went to 2, that means it was reduced. Okay? All right, let's try another one out. Okay. Whoa, there's a lot there. Okay. Ooh,
Oh
a
my
big one.
goodness.
Big one. Yeah. Okay, let's try it out. Let's try this one out. You guys doing this in your head or something?
Oh, we're waiting for you to do it on the board.
Holy smokes. It's really hard to do it in your head. I tell you what, I don't know if I could do it in my head. I mean, I could try. Oh, I found one. Okay. I know it's being oxidized.
You're not a very good example.
And I found the reduced. I found the oxidized and the reduced. I guess you can do it in your head. It's possible.
Not for us. Doesn't have to be the head technique.
Alright, so can you do this on the board and show us?
I would love to. Thanks for the teaching tip.
You're welcome.
I appreciate it. You should be a teacher.
I really should.
Yeah. Okay. Now, CU and S. Okay. Now, not a lot of our rules kind of hit this one. All right. But since S is in column 16, we can assume is a very large word. What?
We don't assume.
Yeah, don't assume.
We don't assume.
We can infer.
Infer, yeah.
We can infer
That's a
S.
stretch. I'll allow
But we
it.
don't assume. We don't assume.
is -2. What's CU have to be?
How can you infer that?
Because I just said it's in column 16.
It's in 16.
How column 17?
-1.
So,
So what?
So column 15 would be column 15.
We can infer that
-3.
in most cases.
So -15 would be.
In most
All of
cases.
it would be -3.
Why don't we just look it up on the internet?
We can some
Some of them.
if
Sometimes.
none of the rules that we know apply to it, we can assume that yes.
Interesting.
Okay? So what must copper be here?
Copper.
2.
How did you get
How did I get 2?
Yeah.
Because 2, so is there a charge up here?
Yeah.
There is.
Does these little part have to equal out? Or like
They do have to equal out.
cancel out?
Okay, so since there's not a charge,
Oh,
that's what I'm left with. What minus 2 equals 0?
2.
2 minus 2 equals 0?
Yeah.
Exactly correct.
Okay.
That's some good math right there.
Okay.
Okay. So here, what's the charge of H plus? 1. Okay, easy. What's the charge of oxygen always? So we got that. Okay, we got -2. Now,
-6.
-6. What? Is there a charge up here? Yes. Okay, so what must my nitrogen be? 5. Okay. Okay. What's the charge here? 2. What's the charge here? By itself. It's just S by itself. 0. What's the charge of oxygen always? -2. What's that going to make nitrogen? 2. What's the charge of oxygen always? What's that going to make hydrogen?
-1. No, +1.
Positive 1. Very good.
Wait, so if an element is by itself, is it 0?
0. Unless it has a charge. Say what?
Will this help me pay my taxes?
Actually, you want me to, can I actually answer that?
Yeah.
Because I love that question. Because I always get questions that, how am I going to apply this? You know, like accounting, taxes. Absolutely. Is this going to help you? Mathematics, yes. Adding, subtracting. Solving different W-2s, you got to plug in information into the tax. Even if you use TurboTax, it's kind of like a game. So actually, when you plug in your information, you have your information, you just got to plug it in. And it's kind of crazy because then if you become a teacher, you have to add up all the receipts that you have, and then you add up so I get things from Teachers Pay Teachers. I buy lab supplies with my own money, right? I got to keep all those receipts throughout the entire year. I got to plug them in a calculator like I'm doing right here and put it in a computer. You don't want to know why? Because I get a tax credit at the end for being a teacher, $250. That's pretty good. However, I don't get $250 because the tax I get like $3. Isn't that crazy? I get $3. That's pretty cool. I can buy like an eraser for that. How cool is that? Now, oh wait, wait, what? I was on a groove.
Keep going.
Okay, so going back to taxes, right? Do you want me to keep going?
Taxes.
I mean, I can go like all day.
Yes. I would
Did that
like
kind of help out? Yeah.
Honestly, tell me. Yeah.
Fair enough. I just don't really like questions like that.
Sorry. Tell me how a human.
All right.
Who won us versus the guy?
Okay. If we look at all these elements, copper is 2 here. What is copper here?
hold on, it's 1. No, is that +2?
Between those two, did it change? No. I don't care about copper. I don't care about it. Let's erase it. I'm getting rid of it.
So there's like 2 sides of the equation.
I don't care about it.
Yeah.
That's the pretty much.
Sulfur. Here it's -2. Here, is it the same number? Changed. Did it increase or was it reduced?
It increased.
It increased. So sulfur is my oxidized.
Oh.
Okay, we found one. We found one.
Where's the reduced at?
Hydrogen. What's hydrogen here?
We get a 1.
What'd you say?
1.
1. What's hydrogen here?
1.
Okay, it's not that one.
And,
Nitrogen. What is nitrogen here?
5.
What's nitrogen here?
2.
2. So 5 going to 2,
It's oxidation.
that's being reduced.
So it's
5 to
Yep,
2
that's
means it's
right.
reduced, right? And we're done.
What's that?
it says oxidation is loss.
Yeah, we lost electrons, which became positive. When we lose negativity, we become positive.
That doesn't make sense.
Did you see my mark, for example?
Yeah, but I was trying to right up till then.
So,
5 to 2, that number reduces.
what we're gonna do is got a little practice. Okay? Got some practice. Now, we're not gonna get this done today. Okay, we got 10 minutes left. But I do want to give you guys this so we kind of, it's good review. And honestly, the back part is what we're going to be learning next week. So I'm actually not going to collect this till next week, if that's all right with you guys. All right. So I am going to give this to you guys now because now we know how to solve 1 through 10. Okay? We know how to solve 1 through 10. Which is pretty awesome. So I'm going to go over an example real quick.
What are we being tested here?
Not for pretty long while.
Alright, because I'm still not feeling that confident.
Okay. So, number one. Number one. Okay. Let's check this out. Okay, number one says we have 2 SRs plus O2 creates a 2 SRs. Okay. Now, looking at this problem real quick. This is number one on the paper. What is an element when it's by itself? What's a 0? Okay.
Even oxygen?
What's an element when it's by itself? 0. Okay. In a compound, what is oxygen always?
-2.
What's that going to make SR, strontium? 2. Okay, so we have all our numbers. SR goes from 0 and it increases to 2, which means that is oxidation.
Yeah.
Okay. 0 to -2 is being reduced. If you go from 0 to -2, you're reducing the number, right? So that oxygen is reduced, and you are done with number one. Pencil, absolutely.
Another one would be.
Oh, are you kidding? Okay. Let's maybe look at number 2. Let's look at number 2. Okay.
Oh, this is difficult,
It is quite difficult.
but I know one of them.
Okay. Let's look at number 2 real quick. Where's my eraser? I have this guy. Ah, there it is. Can I erase this? Okay. All right, so number 2 says, man, all of these are pretty straightforward. I like that. Li, 2 Li's plus S creates Li 2S. Okay. So an element by itself is what? 0. An element by itself is?
0.
Okay. You got those two. Okay, these two. In column 1, what is column 1 usually? 1. Very good. Okay. I have 2 of those. So what must my sulfur be to cancel that out? -2. Very good. Okay, so what is being oxidized? What is being reduced?
Sulfur is being oxidized.
So sulfur, which is 0, being reduced to -2. Sulfur went from 0 and it's reduced to -2.
Yeah, that doesn't make sense.
So from 0 to -2, it's actually being reduced, right? You're reducing to -2. So that's actually the reduced.
Yeah, it says oxidation is loss. 0 to
Loss of electrons. And that leaves lithium to be your other answer.
Don't worry about it. I'm gonna get introduction, not getting.
They're both
blocks.
Okay. So for now, just try 1 through 10.